Perfect. So our bios are up on the website. I just want to say that I'm really grateful to CLEAN for the opportunity to talk about our work on climate change education. And it's really good to see some very familiar faces from previous projects and a bunch of new ones. Peter Mahaffey, I'm a chemistry professor at the King's University in Edmonton, Alberta, Canada, and the director of the King Center for Visualization in Science. I'll tell you just a little bit about that in a few minutes. I've been working in the climate change education space for about 15 years now, and a lot of that work has been done at global levels with the International Union of Pure and Applied Chemistry and other organizations. And my current work is both on climate change education, but also on systems thinking in chemistry education, and that could be the topic for another CLEAN call, and I'd love to connect with any of you after the call about that if you're interested. Melanie?
Yeah, hi everyone. Excited to be back and to talk about our work. So my background is also in chemistry, and I've moved from my PhD through chemistry education in a liberal arts context, then general science education into now a focus on climate. And so I currently direct this project with the King Center for Visualization in Science, and I'm looking to continue working in that interface of raising awareness around planetary health and climate solutions.
Thanks, Melanie. And we've also invited Lynn Andrews from the National Center for Science Education to join us and just make a couple of comments later in the presentation about some work she's doing on climate change lessons, also incorporating the resources we're introducing today. So thanks for joining us, Lynn. So let's begin here. And in the spirit of reconciliation with Indigenous peoples, we begin most of our conferences and meetings at the King's University in Edmonton with an acknowledgement to the Indigenous people who made and make their home in the Treaty 6 region of Alberta. And this is a virtual meeting, so I'd like to ask you to pause for a moment and silently acknowledge the Indigenous peoples who make and made their home where you live and work. As the Truth and Reconciliation Commission of Canada reminds us, reconciliation will never occur unless we're able to be reconciled also to the earth. And so we acknowledge too that before the Indigenous people made their homes in Edmonton, palm trees and rhinos met here some 8 million years ago. And as recently as 20,000 years ago, my university would have been buried under more than a kilometer of ice. And we're deeply troubled to see evidence that in the very short time since our grandparents and great-grandparents were born, the rate of change to the planet's life support systems caused by human activity has caused a great and unsustainable acceleration.
We've seen that before. Mm-hmm.
So we honor and acknowledge today those who work, educators, elders, passionate children, scientists, and artists to reconcile us to the earth again. And in that context, to the participants in the Climate Literacy and Energy Awareness Network call, we honor you for the incredibly important work you do as educators with a very special responsibility for reconciliation to each other and to the earth. And that's a little acknowledgement from our heart at the beginning of this presentation. So the King Center of Visualization in Science, many of you know of us and our resources, an interdisciplinary team of undergraduate students and faculty who create interactive electronic peer-reviewed learning tools accessed now by about 500,000 users from over 100 countries every year. And our mission and vision is to help the world see and understand science. We focus primarily on chemistry, physics, elementary science, and climate change. And the reasons why science is hard to see and understand differ in each of those areas. Physics, hard to see and understand because so many of the forces are intractable. Chemistry, the objects of study are too small to see. Astronomy, they're too far away. Climate change, complexity is a big reason for why things are hard to see and understand. And that's one of the reasons we're also doing work on systems thinking now. We work with partners from around the world. We were founded in 2005. We have about 9 sites and 100 interactive visualizations. And I'm going to be introducing you to 3 of those sites very briefly today. 2 are existing sites, explainingclimatechange.com, vc3chem.com, and then the new one, which launched just before Christmas, Climate Solutions. Explainingclimatechange.com is a resource that was created as a legacy resource for the International Year of Chemistry in 2011. At the time, I was on the Bureau of IUPAC, the International Union of Pure and Applied Chemistry, and was tasked with trying to negotiate to have an international year. And in those conversations, we met particularly with educators and scientists from the developing world who said, we will really happily support an international year, but please, it must have a sustainability focus. And so it did, and this was one of the legacies that was created. It's a set of lessons that give a pretty comprehensive introduction to climate literacy, drawing very strongly connections to the underlying chemistry and physics. It's extensively peer-reviewed by both educators and scientists. And many of the interactive learning materials have also been reviewed by CLEAN and are selected as CLEAN resources. Given our time, I won't take time to go into an example of one, but this is in our slides, and the hyperlink to this is also found on the web that will be available after the call. It's an example of how we build interactive simulations, and these are interactive simulations designed not to tell people what to think about climate change, but to provide them with data, with models, to allow them to ask really good questions. And in this case, we're trying to help students see this really important control variable in the planetary boundaries framework for climate change. Everybody knows about the carbon dioxide variable that we have, the variable which is much harder for students to see, looking at the energy imbalance, the change in balance, radiative forcing of our balance since the Industrial Revolution in watts per square meter. And so we invite students to build a planet and to control only 4 variables: the distance of that planet from the sun, the albedo, the reflectivity. I was interested in your comment, Jean, at the beginning of the call, the greenhouse factor, and the surface temperature. And the energy coming in and the energy coming out have to be in balance. And the surface temperature is determined by those other 3. And this is a way to introduce the feedback loops and all sorts of things that you need to know to get a sense of the parameters that control the radiation balance of our planet. This is scaffolded with a bunch of resources in lesson 4 of explainingclimatechange.com if you'd like to learn more about it. A second resource that a number of people on the call, Ann Gold and Andy Jorgensen, were involved with in piloting some resources and reviewing, vc3chem.com. It was an NSF project in collaboration with colleagues at Purdue and Iowa State University, Oregon, Wisconsin, and the American Chemical Society. And essentially what we were doing here was mapping climate change literacy principles onto general chemistry content. And we picked 4 topics in general chemistry, coming out of which we thought we could map well to the climate literacy framework. Isotopes, gases, acids and bases, and thermochemistry. Developed interactive resources to introduce those topics in general chemistry. And then we actually did some research on student learning as a result of teaching from a rich context relative to the way chemists normally teach. And for those of you who aren't chemists, the staccato presentation of isolated facts is the norm for presentation of chemistry. This work was featured on the cover of the Journal of Chemical Education just a couple of years ago, and I'd invite you to have a look at it if that's of interest to you in terms of university education. And that brings us to what we'd like to tell you about today, but just as a touch point, the other resources that we also have available. And this is Design Our Climate, part of the Accessible Solutions Project. And let me turn this over to you, Melanie.
Thank you so much, Peter. So the Accessible Solutions Project was the point at which I was able to join the efforts at the King Center for Visualization in Science, thanks to a grant from Energy Efficiency Alberta, who have been kindly supporting this work in our province. And so our goal here is to facilitate depolarized conversations around this topic. I'm assuming that all of you may be aware of where Alberta is and what Alberta is. We, I think, might refer to ourselves as the Texas of Canada. Our economy relies heavily on the oil and gas sector, and there is a very strong sentiment locally that you have to either choose oil and gas or choose climate. And so over the last years, we have certainly seen that really large increase in polarization politically and socially in our society. I'm sure that resonates for many of you, as that's something that we're really experiencing also at a global level. But that is where this work comes in, is an invitation to have a curious exploration, design the climate future for our planet, use what you learn in that process to engage in conversations about how we can make these changes happen, and then create an action plan to get active in tackling this challenge. And so we're joined in this project with a few provincial partners, the Alberta Council for Environmental Education, which have partnered with us on the K-12 piece, and they've connected us with people for energy and environmental literacy who have some good online teaching resources also. The Energy Futures Lab, who are our community partner, they work on executive training as well as community outreach around energy transition. And then Student Energy, which you're probably familiar with, who work on the university level globally. And so in this visualization tool, the heart of it is a breakdown of our emissions futures. So we are currently situated at a path, at a point where basically the way we visualize it is we get to decide where we go next. And what we're looking at in that context is the amount of greenhouse gases released every year as CO2 equivalents. So really important to remind ourselves that we're not just looking at CO2 emissions, but it's also including methane, nitrous oxide, and fluorinated gases. At the bottom of that yellow triangle, we have the target, that is effectively set by the 1.5 degree report, and is an extension of the Paris Agreement to remain below 2 degrees, or ideally 1.5 degrees. So those of us who work in this field recognize that there's a cone of a range around that line, but that is effectively your goal. And at the top, we have the worst case business as usual. So Peter, if you want to just click forward one more. Oh, sorry, I thought I had one more slide in here. So at the top, we have our worst case business as usual scenario. Interesting. To kind of bound that. So that's a really overwhelming problem, which we break down using the wedge approach that is inspired by the Princeton Carbon Mitigation Initiative's work. Yeah. And so KCVS first used this in 2011 as lesson 9 of explainingclimatechange.com, where they created an interactive version of the stabilization wedge game as the carbon stabilization simulation. At that time, it became the carbon reduction simulation over time, over the last couple of years, as we realized that we need to actually decrease emissions. And now we have our new tool, the Design Our Climate simulation. So the challenge is, what actions are you going to take? What vision of the future do you have that is going to reduce the number of wedges in this yellow triangle? And it's really important to emphasize that the goal is to just remove as many as we can. It's not a black or white scenario. It's a question of how are you going to get forward in this challenge? What is your vision?
Melanie, I'm just going to jump in with a quick comment. Those of you who have used explainingclimatechange.com, and there's quite a few of you on the call, I think, lesson 9, when we finished this lesson in 2013, as Melanie mentioned, it was carbon stabilization was the goal. Can we continue 8 gigatons of carbon emissions per year? And we found out that you could do that with 8 pieces, 8 wedges. And here we are 7 years later. And the goal is completely different, and the number of wedges that are needed is completely different. So our planet is changing incredibly rapidly, and it's been really challenging over the 2 years that we've been working on this project to keep up with the changes to our planet. So sorry, Melanie, but let me just make that comment.
No, that's great. Thank you. And so there are some learning goals summarized actually on the website too, around what we would hope students achieve through this, or users achieve. And so the first, of course, is to look at where we are currently headed versus where we need to be going, to look at the climate impacts of our current trajectory. And so we'll point that out as we look at the simulation in a moment. As well, you'll see that there's a visual representation of carbon intensity and a little more opportunity to engage with that idea of carbon intensity of energy sources. And then identifying where we have the greatest potential to reduce the amount of greenhouse gases. And in that context, then finding a top 5 list of actions to reduce greenhouse gas emissions by 2050. And of course, all of this will probably, hopefully, lead the user to come to the conclusion that we need a mosaic of solutions. There is not one thing, there are not 5 things that are going to solve this on their own, but we can take a look at what has the biggest impact and where I can get involved locally. And so then thinking about the challenges around that mitigation strategy in our own location versus in places that have a different standard of living. And then really important to identify next steps that I personally can take to use this simulation as a tool within my circle of influence, be that with my friends and family or my communities, to create non-polarizing conversations about solutions. And so a few things that we want to point you towards before we actually go to the live simulation. When folks are first coming to this tool, it's really helpful to take a look at the tutorial, which is this little Carl the Carbon Atom button on the right-hand side, where you'll get some prompts that lead you through some of the features of the simulation to familiarize folks with how the applet actually works. You'll notice as you play with sliders that there is a realistic indicator. So this is a qualitative marker that we integrated to stop folks from just going to extremes on all the sliders, but to then have people kind of alerted to the idea that either due to the current status of technology or due to social factors, they are going into a realm that would be considered unrealistic. And in the debrief, part of what is important is for that to be discussed and challenged and to think about what is realistic. I think our current times are an interesting reflection of what can become realistic. There's a summary feature where you will get a printable page that shows all the different sliders and where they were originally set and what changes you've made. And then for the debrief, the what's next button is really important. So we hope that folks that engage with this tool will spend a substantial amount of time engaging with the what's next feature, because the debrief is of course the most important piece. When you click on a sector, so this is showing the electricity sector, to get into more details of the sliders, you can click either on these bar graphs under sources of electricity, or there's a show controls button to expand so that you can play with, for example, here, the makeup of the electricity network. And we'll possibly do that live here in a moment. You're going to do that right now, Peter?
No, I have a hyperlink there. I didn't mean to click.
All right. And so you'll see here, this is our visual representation of the carbon intensity. When you scroll over that on the simulation, it'll also give you the numerical value. And if you click on the question marks on any of these boxes, it'll give you the assumptions behind each of the sliders. So all of the research is summarized there with linked references so that folks can take a look at where the information is coming from and whether you have other information that would lead you, for example, to challenge what is realistic. So when you get a slider into the not realistic realm, as you see here, the place to go would be the assumptions to take a look at what this is based on. And so we'll see here that some changes in the electricity sector are already making quite a big difference. You've eliminated 6 of the 20 yellow wedges, and the green arrow is moving down, which will also change our climate impacts. I'll talk about those in a second. At the top left, you may see a globe pop up as you make changes. And so there are, of course, certain solutions that have land use requirements. And here then you would be able to take a look at what would be needed in terms of land requirements for that solar or wind installation, noting in the assumptions that, of course, these are dual use or multiple use technologies. And then at the bottom is our visualization of some of the planetary health impacts, the climate impacts that we would invite users to unpack further to think about what these mean at a local scale. So here we have CO2 concentrations in the atmosphere, we have global average surface temperature, ocean or sea level rise, and ocean pH. And these, of course, require some more unpacking, for which we have some resources on the What's Next page.
And those impacts respond to the scenario that you're developing. So you want to bring the wedges down, but you also want to see how that affects the impacts. So shall I go to the resource, Melanie?
Yeah, let's take a quick look at what this actually looks like live.
Just note that there are some teaching resources newly developed.
Yeah, and so those are currently actually online guided activities for remote learning, and they're Google Docs and forums that are open to being copied and adapted. So please take a look and let us know what you think. And so, yeah, Peter, if you want to go to electricity here, so you can see, first of all, as you hover over the different sectors, that it'll give you an indication of the contribution from each sector to the emissions projected for 2100. And then maybe let's take a quick look at one of the common sliders. So the bottom slider there is CCS, carbon capture and storage. And locally here in Alberta, that is the only thing our current government is interested in implementing. And so we can see that it makes a difference. Globally, with current technology, we're expected to be able to take out about 3 of these 20 wedges. And so you can take a look here into the underlying assumptions, the research that is behind this from last summer. But then you get into the not realistic realm with this simulation being based on what is currently possible and currently available. And so you'll see as Peter moves the sliders here, you're taking out wedges and you can see the climate impacts are getting smaller. So that's the colored pie slices or the projections for 2100. Anything else you want to point out right now, Peter?
No, if you work with electricity, this is an important one. We've set this up so that everything in terms of the mix has to add up to 100%. And so we would encourage students to look at this and say, what's the low-hanging fruit? Which of these electricity sources are currently providing the greatest amount? It's coal. And which has the most carbon intensity. And if you start bringing on solar or you start bringing on wind, by default, we have coal. We're taking it out of coal, and then you reach the point where coal's down to 0 and you've got to pick something else to take, and you're going to pick something that also has a very high carbon intensity. And so we can bring natural gas up, we can bring in wind, and this raises questions for your students about, well, can you get there without nuclear? What's the role for geothermal, hydroelectric, and so on? Electricity makes a big difference, and that won't surprise any of you. Transportation, and you can just see some of the controls that are built in here. You can get into detail again on fuel sources, land use, buildings, and again, more detail on buildings in terms of sources of heating energy and materials. And there are, of course, some surprising discoveries that are not normally a part of the conversation so much, public conversation, things like HFC emissions reductions. Anything more you want to say about the resource?
Yeah, maybe do you want to just go to what's next so that we can just take a quick look into the debrief? And because yeah, the idea really is that we want folks to come at the Design Our Climate simulation with a visioning exercise. What do you see the world looking like in 2050? The simulation is for 2100, but we have to of course recognize that these changes have to start now. So really doing a short-term visioning and implementing that. Then thinking about, okay, what is the impact of these different mitigation strategies? Is there a silver bullet? And of course, we come to the conclusion that we hear often these days that we need a silver buckshot approach, a mosaic of solutions. And then climate impacts, as well as really importantly, defining our next steps. And so in that context, our next steps are to more closely integrate the work of Project Drawdown to really engage folks with the suite of solutions that is published here. And so, yeah, before getting into a little more detail around that, just want to hand the floor over to Lynn to talk a little bit about what the National Center for Science Education is doing with the development of their climate change lessons.
Hi, everybody. Good to see you all today. So I've been working with Peter and Melanie for the past couple of months. And I inherited this program, as you guys know, from Brad Hogue, who left to go back to the classroom in, I think, October or November. So what we're doing is we have on our website, which I'll put the link on in just a second, a series. Thank you, Peter, I appreciate that. And so we have a series of lessons, and lesson 5 in particular, we have been working with King Center since the very beginning of the program to have this activity where they are looking for hope and how can we solve these problems, and there is no silver bullet, that kind of thing. And so we have these available already. They are currently being revamped by me. I'm making them a little more teacher friendly, and I've been working on them for the past couple of months, hoping to have them ready to go by summer. And if you guys have any questions about implementation, supplemental activities, my TAs helped John Cook, Dr. John Cook and Brad assemble these 5 lessons, but 5 in particular is completely with King Center, and we are also incorporating some of the King Center stuff into our other lessons. So we just wanted to kind of let you know that there are already activities out there for teachers. I am also trying to figure out ways to make them more distance learning friendly, which is part of the revamp. So if you guys have any questions, just let me know.
Thank you very much, Lynn. And I should have made a comment earlier that one of the things that's at the heart of everything we produce is rigorous scientific review and review by educators. So there are about 25 folks around the world who have reviewed these this latest simulation. I'm going to wrap this up pretty quickly, so there's some time for discussion. The teaching resources Melanie mentioned in the last 2 months, especially since COVID has shut down schools, we've worked very hard now bringing somebody else onto the team to create teaching resources for online learning, right now focused on grade 9 and 10. We have another student working on supporting the linkage of climate change and general chemistry content, kind of taking VC3 Chem much further with systems thinking and this Design Our Climate simulation. And then we're very interested in working to integrate Project Drawdown outcomes at global, provincial, and municipal levels. We do that in a fairly tentative way now by having people finish the simulation and then move to Drawdown, and we like to find ways to integrate that. So let me just end by mentioning some tools that you're going to be familiar with that we encourage people to use in addition to our own, and that's of course Drawdown. And then the Climate Interactive En-ROADS Climate Change Solutions Simulator. And just to have an idea of how we complement each other, I think Drawdown as most of you know, offers global solutions to reach drawdown, the point where we start now starting to come down in terms of atmospheric concentrations of carbon dioxide, and doing that by avoiding greenhouse gas emissions or sequestering CO2. And one of the wonderful things about the drawdown resources are that they quantify everything. They also incorporate costs. And we'd love to find a way to really deeply integrate this into our climate solutions resources. And then many of you are also going to be familiar with Climate Interactive's En-ROADS. It's a comprehensive systems dynamics model. How do changes in energy, economic, and policy systems affect greenhouse gas emissions and climate outcomes? And so unlike what we do and unlike what Drawdown does, this is now getting into the policy world where you can ask questions about carbon taxes and so on and look at the impact that they can have in implementing the changes that come from our tool and from Project Drawdown. So what we do to complement that, it's an educational tool, just to summarize, scaffolded with lessons and activities. Emphasize that it's semi-quantitative, it's a global model, and it's based on currently available technology. So there's no new silver bullet coming in to solve this problem, but we can go an amazing distance with currently available technologies. And that is Design Our Climate. And we want to end by thanking all of you for joining us today. Thanking the KCDS team. This is last year's team that worked. And here's Danny Kroll, who was mentioned, Jim, at the beginning of the call, who was working on an Air Quality Matters project. And here are our funders we would like to acknowledge. Lynn, thank you very much for joining us today. And we'd love to have you connect with us in the rest of the little bit of time we have and in the time after the call. Let us know if there are ways in which you might be able to make use of this and ways in which we can support you in the work that you're doing in climate change. So I'll stop there.
Thanks, Peter. I saw some questions popping in. Does anyone have one they want to jump in and ask right away?
Hey, Kristen, before you get to questions, can I just really quickly, I just wanted to let folks know that we are ingesting some of this into the CLEAN collection. So Peter's submitted the actual simulation. We're going to be reviewing that in our next review cycle that's currently happening. And then Lynn shared the NCSE, and we have some of those actually just went live in the collection this year after the last round of review. So just so you know, these things are getting added into CLEAN.
That's fantastic. Thank you, Katie.
Yeah, that was actually one of my questions. So awesome. Thanks. Anyone else?
I have a question, Kristen. This is Devardi. First of all, thank you for including land acknowledgement. It was great to see that formally and nicely done. My question is, when students integrate or engage with these simulations, is there some way, or during that process, do they compare two different simulations or two different models where they kind of get the opportunity to test their robustness or validity of their data?
Melanie, do you want to take it?
If I understand your question correctly, Devardi, you're asking about using this tool to have students compare different models?
Yes, I mean,
Yeah.
if they're using a simulation, then within a simulation, they compare two different simulations. Or if they're using a model, then comparison of models. And how do you build that in the instruction?
Yeah, that's a really great question. We don't currently have an activity like that in the suite of activities that we're thinking about developing or that we have developed. So yeah, from my point of view, I would say it's not currently part of this tool, but could be definitely something that you could build around it. I don't know if you have something to add to that, Peter.
No, one of the things that you'll be familiar with, Devardi, is one activity that we've developed. This is all quite new. So this was released at about Christmas time, and we're working on lessons. We've developed for a summit of junior high kids and teachers a role-playing game where we divided the students into 5 or 6 roles with different responsibilities, from political to environmental to parents to junior high kids, and then had them think, wearing their hats, how they could come to maybe the COP meeting in Glasgow and recommend what should be done. And then we got them to put their incremental solutions forward, and then we put them all together to see which ones make more difference. I think that was a very effective strategy. I do see a few questions that have come up in the chat. I can just quickly answer 1 or 2 of them. From Wendy, how freely can we use the site in our education activities? I asked because I noticed it's a .com site. These are all Creative Commons licenses, freely shareable. We make them to be used. 500,000 people around the world use our resources. We have .com sites and .org and .ca just so that nobody hijacks our domain name.
So, Peter Melanie, this is Frank Rancho from Portland, Oregon. Can you hear me okay?
Yes.
Okay, good. Going back to the question about comparing simulations, I use C-ROADS and En-ROADS quite a bit in my climate science for non-science majors course that I teach at Portland State. And when I caught wind of your Create Your Own Climate, I decided to sit down and do a spreadsheet setting up 3 different scenarios for Design Your Own Climate and En-ROADS to see how the 2 models would perform next to each other. And I'm happy to share that with you.
Yeah, please.
We'd love that, Frank. Yeah.
Okay,
I've done
excellent.
something similar, but I'd be curious to see your scenarios.
Yeah, well, unfortunately, I got a couple of questions for you in regards to this. Number 1, your label realistic and not realistic. It would be really nice to get some sort of sense what that really means. Why is it? Because I did not find anything in the simulator that told me why is it realistic or not realistic. And I think one of Don Haas responded on a clean that, we don't know what's realistic and not realistic.
I can just quickly comment on that, Frank, and that's probably what we spent more time on than anything else on the scenario, and also lots of consultation. In an area like looking ahead to 2100, how much of our electricity grid globally can be solar? You're going to find a really large range of possible realistic scenarios. And so we have selected one, and so you move the slider, but in every case, when you move a slider, we want you to not miss this little question mark. And this question mark is going to show you what we're assuming. And so the range that we encountered for solar was everything from 20 to 71% by 2100. And so we've landed on something that, in consultation with some of the solar experts that we've worked with, which we think is realistic, but we don't want anybody to believe it because we tell them. We want them to actually look at the assumptions that are there.
Okay. Well, I've got a bunch more questions, but I'll email those to you.
Please do. Yeah, we'd love to.
Yeah.
We'd love the feedback and the questions.
Is it all
I'm
right
going
if
to
I-
be conscious of time. We just have 2 minutes left here. We can jump on with questions. I have to leave, but maybe Frank can close this out for me, or Patrick. Okay, great. I have another meeting. Thank you so much. I'm going to take off, but I'm going to leave it to Patrick to facilitate this.
Okay. Patrick, is it all right if I ask a follow-up question?
Yeah, go for it, Frank.
Wonderful work. I really appreciate the landscape analysis of all these different initiatives. I mean, one of the things we're trying to do in this space is build as much coherence as possible. And that's really why we've built, designed, and sustained Clean, is to try and build some of that coherence. So I'm the, one of the founding members, co-PI and funder of Clean. So I'm really happy that it's doing its purpose, right? So especially in a dynamic way, because new work comes. But the core of my question is some of the work that was done by a group of authors on the powers of 10 cross-scale optimization for social agency for rapid climate and sustainability action. One of the things they found in there, and I put the link in the chat, was that the right scale for this, the sweet spot, as they called it, was somewhere between community and urban focused climate action. Not national, it's not global, it's below that, but across the world, right? So it's all, but the one of the things I struggle with when we talk about, you know, whether it's drawdown, wedges, all of it, right, is that the real work is actually at that urban community scale across the world. And so, you know, when you think about any one community in the world, they're going to, which parts of drawdown you're going to use, or which sets of these strategies you're going to employ is going to be different based on your community. And so I'm just wondering the efficacy of these strategies when you're not taking into account really where your action point for your community where you live is versus, you know, preserving tropical rainforests for afforestation and deforestation reductions, right? That's not a really big thing that kids in rural Wyoming are going to be focused on.
Yeah.
So, I mean, is there anything that you've thought about how to take these and bring them down into community context?
Melanie is smiling. Melanie.
Thank you, Frank, for that question. So many things, because really already in the debrief, that is what we would hope folks engage with exactly, is doing that scaling, because the challenge really is moving between the global issue and the local response and everything in between, right? And so that's part of what we're scaffolding in the online guided activities that we've been putting out now, engaging students in looking at like what are their municipalities actively pursuing, how do their actions actually maybe impact, say, tropical deforestation. One of the things I was just talking about with my colleague is, for example, Canadian mining companies operating in South America and the ways in which we actually do impact things that we don't think are drawdown solutions that are relevant to ourselves locally or to the actions that are being taken by our provincial or national governments. And so, yeah, we're building a lot around that, and are actually this week working for King Center for Visualization and Science on a local initiative with our municipal government to scale it down to the city level. So very much invite that and hope to support that also through Peter's involvement in systems thinking.
We're hoping, Frank, very concretely, we're working right now on trying to translate this to the Alberta context, with the assumption that if it can be done in Alberta, it can be done anywhere, given the economic base in the province, and then also to the municipal level. And there are such interesting differences between the motivations for change at the municipal level in Alberta, Edmonton and Calgary, and the provincial level. And so we're actually working right now on a small funding application, local funding application, to try to do just exactly that at the municipal level. And we'd love to get a little comment from you saying that it's important.
We can take this offline, Peter. I mean, we're seeing in the United States, this exact point is the center of future work. And then looking at the intersectional relationships between organizations and education enterprises, and, you know, but really zooming it in on where is the most active work going to be, and then sharing that across other. So it's a hub and spoke network structure. It's going to be complicated, and it totally bypasses national structure. So I appreciate your approach. So the more you can do to share with us back how that's working, keenly interested in it. It's the front work.
That's fantastic. That's exactly where we're going with it. And it's complicated to take a global visualization tool and now to try to figure out how to visualize that at the provincial level, for instance, because the most common critique that comes back is, well, there are so few people in Alberta, even though our per capita emissions are high, it makes no difference in terms of the global picture. And so it's really important to deal with those strategies locally and to avoid that rabbit hole that politicians want to go down pretty quickly.
Thank
And
you.
I kind of on that note, I would request that as you build that process for Alberta, which will be fascinating given the dynamics there, you can leave a solid roadmap, if you're willing to share it, to consider the choices that have to be made for creating a local simulation so that others who want to do that in their area have a template that they might follow to go that direction as well. That would be really useful. And I know there are other questions. It's an exciting conversation. I'm grateful to have you here, but I also do want to respect folks' time. It's 5 minutes after, and we're starting to see folks drop off. So I think maybe if folks want to continue conversations, if they can contact you and reach out and set up additional calls, that might be the way to go.
Yeah.
Wonderful.
Agreed.
Love that. So thank you so much for having us. And as someone who has attended a climate generation storytelling event at my Minneapolis climate reality training, I'm super excited for their event next week. So I'm going to check that out.
Who's the woman that
Thank you all.
electrical research?
Thanks very much, everybody.
Thanks, everyone.
Ingrid.
Thank you.